Okay, in this lesson we're going to be representing verbal situations, and we're going to be doing that with equations, tables, and graphs. Looking at the student expectations from the state, you are to be able to represent a given situation using verbal descriptions, tables, graphs, and equations. We've actually already looked at these, and we've concentrated on tables and graphs and equations. What we need to do now is go ahead and understand the verbal descriptions and how all four of these work together and represent each other. This is a readiness standard, so at the 6th grade level you are expected to master this skill. Alright, let's look at practice problem 1. It says Olivia has discovered that she likes making bracelets. She can make 4 bracelets in 1 hour. So create a table and graph that represents this situation. Write the equation that represents the table and the graph. Okay, so what we're going to start with here is creating a table. What we know is that Olivia can make 4 bracelets in 1 hour. Let's go ahead and put that in table form. If she makes 4 bracelets in 1 hour, so 1 hour will produce 4 bracelets. Now, let's try to remember here our input and our output. So 4 bracelets can be made in 1 hour. So what it looks like here is that the time determines the number of bracelets. So the bracelets is the dependent variable, and the independent variable is the time here. Okay, so we're going to input 1 hour, we get 4 bracelets. If we input 2 hours, so we've doubled the hours, therefore we're going to double the bracelets. And what if we triple the hours? Let's say we've gone from 1 to 3 hours, then we would triple the quantity of bracelets, so that would be 12. And what if we say 4 hours? Well, in 4 hours she would make 16 bracelets. So here we have our table, and of course this is also our ordered pairs, our input and our output: 1 4, 2 8, 3 12, and 4 16. And I'm sure that you can already see that this is a multiplicative relationship where we're multiplying the independent variable times 4 to get the output. 1 times 4 is 4, 2 times 4 is 8, 3 times 4 is 12, and 4 times 4 is 16. Okay? But first, let's go ahead and let's actually make a graph for this situation. So we have our x and our y coordinates. Let's label this graph by labeling the x-axis, which is also the independent variable. And the independent variable is the time. Okay? So here we're going to put the time, or the number of hours. Time, and we'll put it in hours. Okay? And then the y-axis is going to be our dependent variable is going to be the bracelets, or number of bracelets. I run out of room there to write it, but number of bracelets, okay? And then of course we need to go ahead and put these numbers. So we'll put the hours in units of 1. So we have 1 hour, 2 hours, 3, 4, 5, 6, and so on. And then we need our units for our bracelets. I'm going to do this y-axis in units of 2. So we would have 2, 4, 6, 8, and 10. Now, our first ordered pair was 1, 4. Okay, so that's an x and a y. So we start at 0, 0, and for the 1 we would go over 1 unit, and then the output is 4, so we would go up 1, 2, 3, 4 units, and we would put a point there to represent 1, 4. Okay? Then we have 2, 8. So same thing. We start at 0, 0, we go over 2, and we go up to the 8. And this would be 8. Okay, I'm going to put one more dash here that represents 12. And let's plot the 3, 12. So we go over 3 and we go up to the 12. So you can see here I've plotted those 3 ordered pairs. Let's think about one more real quick. What if the x had been a 0? Well, if the time was 0, then she would not make any bracelets. So really, we could actually put a point at 0, 0, which is the origin, 0, 0, and let's draw a line through that. And now we have the graph that represents this table, and both of these represent this situation. Finally, though, I want to put an equation to this. And let's remember the equation. We need to find the coefficient because this is multiplicative relationship. And the coefficient is what we're multiplying times the independent variable here. So we're multiplying 1 times 3 to get, 1 times 4 to get 4, 2 times 4 to get 8. So the relationship is times 4. So our equation then would be y equals 4x. So we have an equation, we have a graph, a table, and a real-world situation that all represent these ordered pairs, and it represents the idea of making 4 bracelets in 1 hour. Okay, let's take a look at one more example. So in practice problem 2, we have a laundromat that charges $5 for a box of detergent and $1 for each load of laundry. And then again, we're going to create a table and a graph to represent this situation and write the equation that represents the table and graph. Okay, so the laundromat charges $5 for detergent and $1 for each load. All right, let's start by creating a table that represents this situation. So I tell you what, I'm going to draw this table a little different just to show you that it can look different. We still have an X and a Y, an input and an output. I'll put the X and Y in here. Now let's think about what we're comparing. Basically, this is what we're working with, $1 for each load. Well, you might wash 2 loads of laundry or 3 loads of laundry. Okay, so that's what we're going to try to determine what it costs. But let's look at the laundromat charges $5 for a box of detergent. Okay, so before you ever wash a load, you've got a $5 that you're going to have to add to the price of washing a load. So plus $5. This is important. Let's remember this is called our constant. Okay, so if you wash 1 load of clothes and you've already also spent $5 on the detergent, then your total for that 1 load would be $6. And if you wash 2 loads, and you remember that that's $2 for each load of laundry, or that's $1 for each load of laundry, which is 2, but then there's the $5 for the box of detergent would put you at 7. And then finally, if you did, let's say, 3 loads of laundry, well, that's $3 for just the load and then $5 for the box of detergent. And I think you get the point. We are adding $5. So the relationship here is an additive relationship, and we're adding 5 each time. Let's create a graph that represents this. So we have our X and Y axis. And let's label the X and Y axis, remembering that the X represents the independent variable and the Y represents the dependent variable. Alright, so The independent variable is going to be the loads of laundry. Number of loads. Number of loads is the independent variable. We may do 1, we may do 3, we may do 5. Well, that is going to determine what it costs. So our independent variable is our dependent variable then is the cost for doing the loads of laundry. Okay, so with our independent variable, the loads are going to be based. Let's see, we have a 1, 2, 3, 4, 5, 6, and so on for our loads of laundry, and then the cost. I'm going to do the cost. Let's go ahead and do the cost by 2's. So we'd say 2, 4, 6, 8, 10, 12. And let's label those $2, $4, 6, 8, 10, and 12. And again, those are in dollars. Okay, and let's plot our ordered pairs. So we have a 1, 6. So we would start at 0, 0, and we would go over 1 on the x-axis and up to 6 on the y-axis. And I'll go ahead and place a point at 1, 6. Then we have a 2, 7. So we go over 2 and up to the 7. It's really just $1 more. That's the $1 for the load of laundry. Okay, and our 3 is an 8, so an x of 3, a y of 8. So we go over 3 and up to the 8, and I'll put a dot there. Now let's think about, I don't have it in the table, but what if the x had been a 0? Let's say, let's say the x was 0, or the input was 0. Well, in this case, even though you haven't done a load of laundry, technically you have to spend the $5 before you do any loads of laundry. So it would actually be a 0, 5. So at the origin, we don't go right or left. It's a 0, but then we go up to the 5, and that's where we would start this graph at 0, 5. And we could draw a line, and it would continue on in that manner. So this is your graph, and this is your table that represents this real-world situation. Last thing real quick, let's include the equation. Remember that this is an additive relationship, and we're going to write it in terms of y and x. So y is going to be equal to the x plus 5. Whatever we plug into x, we add 5 to it. Okay, so that is a look at representing verbal situations using equations, tables, and graphs.